Hello, welcome to Macroscopes in Action. We really appreciate you coming out on this drizzly day to join us. Welcome on behalf of myself, Todd Theriault, my colleague Liesl Record, Katy Börner, who's joining us remotely. We are the authors of Atlas of Macroscopes, Interactive Data Visualizations, which you saw on the way in. And if you like the way it looks, part of that is due to the talented macroscope makers whose works we're going to look at today. And part of it is due to Tracy Theriault, who's sitting in the front row, who is the designer of the book. So Liesl, Katy, and I are curators also of the Places and Spaces Mapping Science exhibit. And so we love visitor surveys. So we're going to do one right now. By a show of hands, how many of you are from academia? Thank you. How many are from industry? Oh, nonprofits? Okay, thanks. And how many of you create data visualizations? Okay. Nice, thank you. And is anyone here familiar with the work of Places and Spaces Mapping Science exhibit? Curate. 2, okay. Great. So we have some work to do today. All right. Excellent. So let me just familiarize a bit with the exhibit that is the inspiration for the book. Between the years 2005 and 2014, the Places and Spaces Mapping Science exhibit worked toward the goal of bringing maps of science to the general public. And this task took us all around the world. To libraries, museums, conferences, festivals, trains, office spaces, everywhere that there was people gathered, we wanted to be there to introduce science maps to them. And so you can see over the course of a decade, we collected 100 maps from 215 map makers from around the world. And in that collection, were featured what we consider to be some of the best examples of knowledge domain mapping, novel location-based cartographies, data visualizations, and science-inspired artworks from leading figures in the sciences, scientometrics, visual arts, public policy, and the humanities. However, towards the end of that science map decade, we found ourselves including more and more on the website and on the object labels that accompanied the maps, web links to animation and tools for which the static images were only glimpses. And so we were finding that increasingly there was just this whole level of movement and life and activity that we just couldn't capture with a static map presentation. And so we took that opportunity of it being 10 years to shift our focus a bit to something else. And we felt that the exhibit static maps were important because they showed the results of scientific exploration. But now what we wanted was something that would invite viewers to explore science themselves. In other words, if the static maps were thought made visible, what we were looking for was thought made active. Something where exhibit goers themselves were invited to collaborate with makers in sharing directly in discovery. And so we decided to use that 10th anniversary of the exhibit to shift our focus for another decade-long commitment to macroscopes, which we'll be talking about today. And that became our focus for the next decade up until last year, 2024. So when I tell friends and family that I curate an exhibit that features macroscopes, they're usually like, that sounds like something I should be familiar with, but maybe it's not as familiar as we would hope. And so I try to come up with an example that a lot of people might know so that, oh, okay, that's sort of what we're talking about. And in fact, back in 2020, my family and a lot of people I knew had a deeply emotional intensely personal, perhaps somewhat obsessive relationship with a macroscope. In fact, each day, sometimes several times a day, we would peer anxiously through the lens of this macroscope. And what we saw there determined whether our day would be one marked by anxiety or relief, optimism or worry. Back in 2020, the macroscopes that had such importance for many of us were something like this. One of the many web-based dashboards tools that track the spread of COVID-19. Depending on our interest, we could choose a global tracker like the one from the World Health Organization, a national model like this one from Johns Hopkins or the CDC's model, or a more local version like the one produced in Indiana, where I live, by our State Department of Health. For me, at a time when it was really easy to feel overwhelmed with information, these COVID macroscopes brought a sense of clarity, order, and insight. They took massive amounts of data and made it both legible and usable through visualization. Huge spreadsheets of numbers and statistics and geographic coordinates became elegant maps and graphs that clearly communicated COVID's scope and spread. Just as importantly, I think, these macroscopes respected the human dimension of data by making them interactive and personalizable. So you could filter data to inform travel decisions for you and your family. Or you could direct your search to monitor the situation of loved ones in other locations. For many people, this was an experience with a macroscope that could be at times as emotional as it was informative. So now that we've seen a perhaps familiar example, just to get us started, of a macroscope, we'll take a step back and look at macroscopes more generally.
So as the name suggests, a macroscope is an instrument for making large-scale entities visible to the eye. So you're familiar with other scopes like microscopes and telescopes. Like those, this is also a lens that allows us to see things that we wouldn't otherwise be able to see, perhaps things that are more complex or larger scale than we can see with our little eyes. The term, let's see. There we go. The term first appears in scientific literature in a number of different areas, starting as early as the 1950s, but it really received its fullest articulation in Joel Durazne's manuscript called The Macroscope, A New World Scientific System. Durazne is a French biologist and a computer scientist, and really focuses on the future of research technology. And he pictured the macroscope, in his words, as, quote, a symbol of a new way of seeing and understanding. It was to be a tool, quote, not used to make things larger or smaller, but instead to observe what is at once too great, too slow, and too complex for our eyes. Durazne includes in the book some line drawings, such as the one behind me here, that give an idea of what he meant by a macroscope. He's looking at these large-scale systems. Here he's illustrating economy, and he's showing, you can see he's looking at systems that have a lot of relationships, a lot of motion, and a lot of complexities. Let's see.
Yeah. So having collected, supported, and promoted macroscopes as curators of the Places and Spaces exhibit for over a decade, and now having written about them as co-authors of the Atlas of Macroscopes, we have seen firsthand the power and potential of these incredible tools. The macroscopes we feature in our work combine high-quality data sets, computational power, and data visualization techniques to provide a big picture view of subjects that are often, as Lisa mentioned, too large and too complex to fully comprehend from an individual perspective.
The one component that all macroscopes have in common is that they are foundationally dependent on data. This macroscope, which you can see here, is titled Spain Lives in Flats. It provides this beautiful bird's eye view of Spain's built environment. So you fly in over many of Spain's cities and you can see the outline of buildings, the volume, the roof lines. It's pretty incredible. But the seamless view belies the amount of data collection and cleaning that makes this visualization possible. This macroscope was developed as a journalistic project by an online newspaper based in Spain. Data that included building footprints and property boundaries for more than 12 million properties. Every building in Spain was downloaded and combined into a single database. And then it was confirmed, building construction dates were verified, building heights were calculated. All of this was put together into a single database, and that's what's behind this beautiful scenery where you're flying over, over cities in Spain. The project involved massive amounts of geographic data compilation, processing, and analysis. Access to large data sets is critical for building robust, meaningful macroscopes. Open access data can be a great source of material. As a case in point, I'd like to introduce a macroscope that relies on New York City's open access data. This macroscope was a joint project, Transportation Alternatives, a New York City-based nonprofit, worked with a team from MIT in order to make 23 data layers visible using existing open data resources. So this included spatial data on things like traffic injuries, tree canopy, public bus speeds, and how much seating was available in public areas throughout the city, along with many other things. It is geared for citizens and their representatives to give them access and to analyze data related to their neighborhood and their city, particularly for the purpose of advocating for change. This macroscope would not be successful without that marriage of open data with a well-designed interface.
So as we have mentioned, one of the strengths that macroscopes possess is the ability to offer a big picture view of a topic, whether that's worldwide weather patterns or structure of the cosmos, healthcare inequalities, or refugee migration routes. Macroscopes can help make sense of it. When faced with topics of great complexity, the motto of the macroscope is it's complicated, but not incoherent. And this is what makes macroscopes so very vital at this moment in time. In an era marked by worldwide ecological disasters, destabilizing international conflicts, and global pandemics, we are reminded daily that we exist within a deeply interconnected global network. What this means is that some of the most powerful forces that shape our lives may not be so simple, local, or linear. They will likely be multi-causal, far-reaching, and contain lots and lots of moving parts. To make sense out of this tangle of connections and contingencies, many macroscopes employ network models to reveal the key economic, medical, political, educational, and ecological relationships that shape our lives. These relationships can be difficult to see even on a local level, but on a global scale, they are often invisible to all but experts. Take the global food supply chain. We all might intuitively understand how a problem with grapes in Italy could lead to a shortage of wine in Europe. What's less obvious might be how a shock to US soybeans can affect pork and poultry production in places like Panama, Egypt, and Indonesia. But these are just the kinds of dependencies that become clearer when interacting with the whole picture from the Complexity Science Hub in Vienna, Austria. Utilizing a sizable collection of production and trade data alongside a network model that accounts for both food and the materials needed to produce it. The macroscope depicts the effects of localized shocks to agricultural production on specific markets around the world. Through intuitive functions and elegant design, this macroscope powerfully conveys the interdependent nature of our global community. Macroscopes are well suited to take in data from elaborate systems identify patterns through analysis, and reveal vital relations that might be obscured by that system's size and complexity. And this is especially useful when dealing with difficult social problems, for which there are often no clear-cut causes or one-size-fits-all remedies. During the height of the opioid epidemic in the US, the National Opinion Research Center partnered with the Appalachian Regional Commission to create the Appalachian Overdose Mapping Tool. This interactive dashboard brought together a wealth of drug mortality and demographic data that allowed users to compare county-level overdose rates with the socioeconomic conditions in that area. It's in pink. Like most macroscopes, the Appalachian Overdose Tool is designed to be not only useful to experts, but also accessible to everyone else. Its intuitive interface and easy interactivity make it possible for a broad range of users to dive right into the data and begin pursuing their own lines of inquiry. This wide on-ramp into the data means that everyone, from researchers, journalists, and policymakers, to healthcare providers, community leaders, and the families on the front lines of this epidemic, to make informed decisions about where limited resources might be best directed. Indeed, the mapping tool proved to be so useful that the Department of Agriculture commissioned a national version to be built in 2020. As portals to continuously evolving data, macroscopes can serve as windows to the dynamics of any terrain, personal or professional, local or global. This incredible topical range becomes evident by taking even a quick glance at the subjects covered by the macroscopes, both in the Atlas of Macroscopes and in the Places and Spaces exhibit that inspired it. There you will find macroscopes to help us better understand complex topics like economic inequality, healthy urban planning, public well-being, the global media, international research collaborations, and the changing job market. You will find macroscopes that cater to a wide variety of interests, from astronomy to ornithology, from news to politics, and from history to food crazes.
So macroscopes are really a marriage between data and interfaces. Both are equally important. The interface can guide us through a user story, or it can provide a playscape for exploration. So macroscopes really fall somewhere along that continuum. There are some that very much guide you specifically through a story, and there are some where you can experiment with all kinds of things and personalize as you wish. The US water crisis, this macroscope here, is one that was one of the first that we included in the exhibit that used a very structured storytelling format. It's called scrolly telling, which is a mashup of storytelling and scrolling combined. And it really takes you through a very specific story, showing you using different graphs, using government data to tell the story of why the water crisis is so pressing. It goes through uses different visualizations, pulls them in, and builds evidence as it goes through the story to support its thesis. At the other end of the spectrum on that continuum from explain versus explore is an alternative-driven country map, which is made for manipulation. You can manipulate 32 different variables, all kinds of different metrics related to countries all around the world, includes all of these countries in the macroscope. So you can compare and contrast countries based on different combinations of metrics. Then the macroscope uses a machine learning algorithm known as t-SNE to place countries that share those similar metrics that you've selected next to each other. So you're not looking at them geographically, you're looking at things in proximity based on similarities in the metrics that you've chosen. You can additionally color the countries based on 20 different criteria, including, for example, the Happy Planet Index score. So it's a really broad way of looking at countries and just playing to see countries that are similar in ways you might not have thought.
So, and while macroscopes, we feel are tools of intellectual exploration and discovery first and foremost, they're often capable of really incredible beauty. The Barabashi Lab's Nature 150, for instance, conveys the importance of intellectual influence by creating a galaxy-like network of scientific papers and allowing users to explore them by flying through a colorful constellation of nodes and links. Elsewhere, the graceful lines and vivid coloring with which the macroscope Earth by Cameron Beccario visualizes global weather patterns give it a beauty that could rival something that you'd see hanging in an art gallery. Macroscopes can be a vehicle for the type of intellectual pleasure that accompanies the acquisition of new knowledge, the discovery of a hidden connection, or the arrival at a new insight. But, and I want to emphasize this, they can just be a lot of fun to play with. For instance, Matan Stauber's histography, along with giving us a conventional timeline through the billions of years he tracks, also in the original version and purely for the fun of it, gives us a time spiral where we can dizzyingly loop our way backwards billions of years and see some interesting points along the way. One of the newest macroscopes and one of my favorites is River Runner. What you do is you begin by placing a virtual drop of water anywhere in the world, and I put mine, boringly maybe, in Bloomington, Indiana, where I live. And you can watch as it makes its way through streams, tributaries, and rivers, tracing a path to the ocean or an inland sea. Hydrologists at the United States Geological Survey collaborated with the Internet of Water Coalition to create a database of the world's interconnected watersheds. And River Runner is the visualization of that interconnectedness. This soaring perspective allows for amazing views of the landscape while also showing the distance a water drop travels to complete its water cycle. I find this delightful because as a kid, this is how I would explore maps, right? The atlases you'd read in the back seat of the car, paper maps, obviously. And traveling with my finger as sort of a car, finding the best route from one place to another, or pretending to be sort of a bird flying over the landscape. And so for me, this captures a nostalgia, it captures a childlike joy of imaginative map exploration. And this is one of the reasons I'm really attracted to macroscopes. Some of my favorite ones are not merely conveying information, right? They are generating curiosity, encouraging exploration, and engaging the emotions.
So macroscopes are ephemeral things. I think a number of you suggested that you develop interactive visualizations, so you're well aware of this fact. They're short-lived creatures. They're susceptible to slight changes in their environment. So updating a browser or maybe making changes in security settings can be fatal if you don't have ongoing support. 10 years is really an eternity to keep some of these macroscopes going. Interactivity is difficult to archive, even using the Wayback Machine and other venues. It's difficult to keep this experience of exploring a macroscope alive. Preserving the data is also important and challenging as well. And for all of these reasons, we've also stepped up our efforts to preserve these visualizations through other means, such as videos that document the interaction, interviews with macroscope makers, which you can find on our website, and also by documenting through the Atlas of Macroscopes book. The growth and the development of interactive visualizations over the past 10 years has been exciting to witness, and we're committed to preserving a record of it.
So now we're going to go remote and welcome Katy Börner to our talk. And Katy, welcome. And I'll just advance the slides when you tell me to.
Thank you, Todd. It's wonderful to see you all. Thanks for coming out. It was planned that we all three would be there together with Tracy, who is the designer for the last 4 Atlas books. So you might see the Atlas of Macroscopes out there, but they're actually a collection of 4 books which now have been created surrounding the exhibit. You might wonder what is next. And so we have been debating this for a long time with the Exhibit Advisory Board. We thought virtual reality would be next, but I don't think it's ready for that yet. So I think it's not a change in the interactivity and in the touching and feeling of data that makes the difference here. But I think what we really need to understand all better, especially with large language models becoming more and more powerful by the minute, is how we interact with other intelligences. And we don't want to just constrict this, restrict this to AI and us, but instead we are interested to engage with the real world. And so here you see Amatria, which is hanging in Laddio Hall. This is our work environment. We actually pass by Amatria every day when we get our coffee. And inside of Amatria, you have many sensors and actuators, and you can interact with her with your entire body. And so on the next slide, you get to see what kind of sensors exist. So you have infrared sensors, microphones, you have actuators such as light and speakers and vibration motors. So you can actually wave by and it kind of waves back to you and actually does this with the entire body of the sculpture, which is quite beautiful also. And then on the next slide, you see a more interactive data stream that is generated based on a hand waving by and then the undulating movement going through the entire structure as a response. And so in addition to us interacting with these sentient architectures created by Philip Beasley at the University of Toronto, on the next slide, you see our vision for the 3rd decade of the exhibit, which will be on envisioning intelligences. So multiple intelligences, the human microbiome and us, fungi and trees, bacteria and viruses. All of these are interacting with each other. And in many cases, we depend on them doing the right thing. Definitely when we want to eat something and digest it and use it as nourishment for our human bodies. We absolutely need the microbiome. And I think we understand very little about it. And again, data visualization can help us make better sense of the world, eat better, do the right moves in exercise as we get older or if we are young. And on the next slide, you will see that we are focusing on all kinds of intelligences, including linguistic, kinesthetic, communication, musical, emotional, and others. We are interested in collaboration and coordination, but also a little bit of competition is useful often. And we want this across life forms and intelligence types. And we would like to use the exhibit to inspire a discussion about existing and future sensors and actuators, memory and reasoning, exploration and communication, but also shared goals and desirable future. So just like the 3rd Atlas is trying to help everyone understand what kind of computational predictive models exist that can be used to simulate the future before you sign the check or before you make a certain decision, so that we arrive at more desirable futures together, and that these are desirable futures for all of us, not just for a few, is, I think, very, very important. So this 3rd decade will be focusing on that. And we are super excited to have a first set of applications accepted for the exhibit. They will be presented soon in a physical setup, but also will be presented by their makers with the stories that surround them in the 24-hour event. And on the next slide, you see more information on this 24-hour event on envisioning intelligences. We have done this 4 times now. It started during the pandemic when everybody was locked down and we couldn't bring the exhibit to libraries and museums and other places. So in fall of 2021, we had the first exhibit on science maps, and many of the hundreds of maps makers, they came in and they explained the stories behind their maps and explained how these maps were created. And then in 2022, maybe more relevant for the Broad Institute, we had an entire 24-hour session on the Human Reference Atlas. And again, some of you are actively involved in constructing that atlas. And there's also now first users of that atlas, even though it's still in the making, but some functionality exists now that is relevant for research and is starting to become relevant for clinical practice. And then in 2023, we had a 24-hour event on macroscopes, interactive data visualizations, which actually goes well with the Atlas of Macroscopes. So you will have many of these interactive visualizations preserved because of map makers explaining them in front of a camera. And this way, hopefully, if we keep good track of the YouTube and other video streaming services, then that will still exist, even though the interactive data visualizations might not work any longer if data streams stop being in existence, or if software updates don't happen. So it's actually non-trivial to keep so many interactive data visualizations alive, as Liesl already pointed out. And then last year, we had an event funded by CIFAR, which is a Canadian institution, on the multiscale human. This CIFAR effort brings together researchers around the globe interested in creating multiscale maps and models of the human body. And again, you're very welcome to click on these links and to check out the presentations that happened there. I think you will have many names that you would recognize. For this year's event, we have a number of confirmed speakers, and actually on the website, you now have a lot more speakers confirmed in the meantime. And we hope you can join us for a few of the hours. I don't recommend doing all 24 hours in a sitting, but they are all recorded and you can enjoy them later. And on the next slide, very importantly, I would love to thank my partners here, so Liesl Record and Todd Theriault and Tracy also as designer. We couldn't do it without her. Thank you from the bottom of my heart for being in all of this for the last not quite 20 years, but almost 20 years now. There is also an extensive exhibit advisory board. Many of these experts have served for 20 years, and it's just marvelous to do this together, to bring this exhibit to so many venues, to inspire people to get excited about science, about data mining, data visualization, and ultimately make their own maps or connect to the map makers that have the expertise and work with them, collaborate with them. So that's also an important piece that we do to do this matchmaking between those which have data and great questions and the macroscope makers and map makers that are always interested in high quality data sets and good collaborations. So again, thanks go to all of you, and thank you also for supporting this exhibit. Todd, back to you.
Yes, so before we go on to this next portion, where we invite you to explore the macroscopes with help of the laptops there, I do want to thank a few people at the Broad Institute, Kristen Ardley, for connecting us with this beautiful institution and these wonderful people like Brady Walker and Lisa Anderson, who are so kind and accommodating to help us get set up, to have Katy be able to come in. And we have books for Brady and Lisa too, to remember us by. And then also Kyle Benson, who I met this morning to help us with AV. So thank you to him. And then at the MIT Press, we'd like to thank Rebecca Kahn, who is out there with our books. And it was wonderful that she was able to come. To Gita Devi Manaktala, who has shepherded the Atlas series from books 1 through 4, has helped really guided that through the whole publication process. And so we'd like to thank her. The next Atlas that's in the works is being overseen by Esteban Moro at the Atlas, or at MIT Press, and Carolyn Helms. And for this round, for the Atlas of Macroscopes, We would like to thank Katie Lewis and Nicholas Sabatini, who were so instrumental in getting us promotion and getting us everything we needed to support the book. So with that, we can have a time of questions, answers. There's also this Scan Me, and you feel free to use the laptops here or your own device. Phones are maybe not the best for all of these. It is better to see them on a bigger screen. But we will stick around, and if you have any individual questions as you're looking through stuff, please don't hesitate to ask us. But if there are general questions now, we have a little time to.
Hi, thank you for this. I had not known about your organization before I stepped in here, basically. So if you can give just a little bit of a high level of, I mean, I understand that you see the value in visualizing data and all of these things, but just almost the logistics of it, like what kind of an organization is it? Who do you, I don't know, there is funding for it. Do you provide funding for others? Do you seek collaborations, or it's volunteer-based? Journalists just find out about you. How does it work? How do you work?
Okay. I will let Katy or Liesl take that since they've been things the longest.
I'm happy to take that.
Did you hear the question?
Yeah, I totally heard it. Yeah, thank you so much. Great question. So 20 years ago, we had a breakfast meeting, and we thought, oh, we have all these maps of science, but only those which can actually pay for them, which are typically the national labs, major funding organizations around the world, really, and others involved in systematic science policy making. They got to see it, and we thought it's a shame, because we all might like to see how science evolves and where our career trajectories go, and how also job markets and classes change over time, etc. And so we got together and we invented this exhibit. And initially it was 10 maps, so they were easy to transport in a car. And then over time it grew to 100, which you can't transport in your own car any longer. So we have this exhibit as an organization that basically operates like a journal. So every year there's a call for maps or macroscopes, or now intelligence data visualizations. And people from around the globe submit. Oftentimes we have 30 to 50, sometimes more submissions. And then the exhibit advisory board, plus others, which are relevant for different iterations, they get to review these contributions and then pick a winning set. The winning set typically is not yet ready to be in front of general audiences. Sometimes it's publications that made the cover of a journal, but that's not yet in the right format to have it in a museum setting, for instance. Or some of the macroscopes had a different aspect ratio, and they had to be fit to that exhibit kiosk. And so that then requires that our team works very closely with the also teams to fit it in the either framed map format or into the macroscope kiosk, or the new formats that the third decade of the exhibit has, which has a lot more cameras and interactivities than we ever had before. And ultimately, the team changes over time. The exhibit advisors change. The exhibit curators have been changing. But the three of us have been doing this for quite a while now together. And it has been, again, a true pleasure to then have these sets of maps and macroscopes and bring them to many, many different places. In many cases, the exhibit venues pay for shipping, which is substantial, and then also pay fees for having the exhibit elements on display. It's not a profit making, it's a losing business. So be careful what you wish for if you create an exhibit, but it's a very rewarding expertise and experience. And so I highly recommend anyone to create exhibits for those which really would like to see more science outreach, science education, communication. I think it's very important, especially right now, to have more people embrace data and data analysis, visualization, models of science. and also models of scientific data ultimately. And we in return get a lot of great input in what works and what doesn't work. We can use this in our research. Oftentimes, collaborators from the exhibit become collaborators in research projects that we run at CNS, that's the Cyber Infrastructure for Network Science Center, which is financing most of the exhibit, especially those parts which don't get financed by venues. Like we oftentimes have venues in Africa or Latin America, and then we finance those from our budgets. So again, it's a pleasure, but it also does cost quite a bit of money. So the exhibit reports, which are all available online, also show you the budget for the exhibit.
Thanks.
And there might be some exhibit reports also in the handout section.
Hello, hi. So I was wondering more about data literacy, because it seems to me that there is these like plenty of these atlas around made by talented people, and they're amazing. But sometimes to me it seems that they live like in this internet space, in this cloud. If you're, I don't know, lucky enough to find one of these and you can explore it, maybe if you're really interested, you could have like an exploration of 1, 2, 5, 10 data points, but this is maybe for the general audience. So my question is, how do we move from this exploratory approach to a more actionable insight where we explain people how to use these tools in order to make informative decision, right? So policymakers, and how to use these as a tools for research and policies rather than just an exploratory experience.
I'm happy to do a first pass on this.
Yeah.
So during COVID, people actually had an increase of their data literacy because they had to read a lot of data graphs. They got to see them in the news all the time. They learned about flattening the curve, which was a complicated term for many. In general, I am concerned about decreasing data literacy, maybe just like you, because now logarithmic scale apparently is not allowed any longer in certain environments. So you have to have linear scale instead so that everybody can understand it correctly. So I think we need to get away from this. And the only way you get away is by actually making your own data visualizations. So much what our center is doing is to create tools so that people have an easy way to read data, clean it more, interlink it, clean it ever more, analyze it, ultimately visualize it. But they have to definitely always do the cleaning part. So if you don't like data cleaning, it's an issue. But with these tools, you can then learn what works and what doesn't work when certain problems arise. And I think it's very similar to being able to read and write. If you just read but never write your own story, that you have a totally different take on what is feasible and possible. And similarly here also, students that take the information visualization MOOC, which is a massively open online course, or the visual analytics certificate that we also offer to not-for-profit and industry institutions. Both of those teach temporal, topical, geospatial, and network analysis and visualization to answer when, where, what, and with whom questions. And oftentimes we have real-world clients with good questions and excellent data, but no money, no funding initially, because they just learned about data visualization. And so they come in and get first pilot analysis and visualizations and can then use that to apply for more funding. And then coming back to action, that's a very good one also. Very great question. Typically, if you just understand that you should do more sport or eat more salad, that's not good enough. I think you have to be touched emotionally. And the exhibit can do that. I, as a researcher in a scientific presentation and paper, I'm not supposed to try to get to your emotions. But with the exhibit, bringing that to science museums and to libraries, we actually can start to get a little bit to your emotions. And I think some of the examples you saw today, the COVID epidemic or the opioid epidemic and other maps about inequality, they are very, very important pieces of information to take into account and to also act on ultimately.
I've got something to add to that too as well. I think that part of our drive in wanting to share this information with the public is that some of the research that we found was that people are exposed to data visualization and taught about data visualization in middle school, perhaps in high school, and that's it. So in terms of the general population being able to look at and understand data visualizations, you learn in that one time period in your life, and then you move on and things change very quickly. And so there's not a lot of information about how to read a data visualization out there in the world. So that's one reason we feel like it's important both to be using it in a subject, in a subject matter expert way, but also to help people build those tools that they need to be able to interpret the data visualizations that all of you are building.
And I think also Esteban Moro's presentation was excellent in this respect, because I think I will now start checking out the environments where I should go, right? Nero, Starbucks, Dunkin' Donuts. I want this mixture. I think also the exhibit is always trying to create spaces where people from all walks of life meet each other, talk with each other, and potentially do really neat projects together. Or just go on a walk and talk and enjoy each other.
Thank you. Any other questions?
Hi, yeah, this stuff is all fabulous. I mean, following on, I guess, on both of the first two questions, do you have a sense of how the authors are funded to make this work? Because as you alluded to, there's sort of like a lot of operational challenges and experience and skill required to build these things. And, you know, especially for things like outreach where there isn't a ton of money around, you know, how are people funding this work?
So my best estimate is that each one of the macroscopes, the interactive data visualizations, is about $100,000 US. And some might be cheaper because some infrastructure already existed and they can use it. But typically that's about the right number. Keeping that up to date, many of these macroscopes are using real-time data feeds, is also non-trivial. Keeping it up to date for 10 years and running on different versions of operating systems, also non-trivial. So it's not just the initial expense to create the first version, but it's also updating it regularly so that it becomes not obsolete and also is working on the new operating and other systems is challenging. We started to create videos of these macroscopes just also to preserve them. We believe they're valuable to have as a resource. Ultimately, I believe what is happening is that the exhibit helps the makers of the maps and macroscopes to get connected to people which have high quality data, great questions, and also funding ultimately. So we have seen that in many instances that people which got picked for the exhibits and also get to collaborate with some of the colleagues we knew beforehand, or new colleagues and new experts and new data sets. And I think that's exactly the kind of virtuous feedback cycle that we would like to create as well.
Thank you for that question. Any other?
And maybe people want to play. I think that this is really best if you play on it. So we just presented the exhibit and the book also in Budapest, and they rolled in a humongous screen. And people were busy, especially as a team or multiple people from different teams, to really explore them for more than an hour. You might not have this time right now, but please do come back to this web link, scan me, and show it to your family members, get their comments on it, show it to your mom, to your daughters, sons, others, colleagues. The more this knowledge spreads, I think the better we all together will be off.
Thank you for coming, and we invite you to come play with the macroscopes themselves.
Very much appreciated. Thank you.
Thank you all.